6.7, inverse relations and functions. Relations are still going to be an equation or a group of numbers, but are not functions. How do you know if a graph is a function? Remember, if we have something like this, you always do your vertical line test. Now, one thing about an inverse is the exact opposite. And if you look at this right here, basically, if this was what was given, this is my domain, my input, my output, an inverse is going to be just flip-flopping these two. So your domain now becomes your range becomes your domain. Now, one thing that's nice, when we have the vertical line test, we know if it's a function. And if you see that same function, and if you do a horizontal line test, that will tell you if the inverse is a function. Now, one thing, when we actually get into graphing these, if I write the inverse of this relation x, the inverse a lot of times is going to be graphed with a -1 here. That means it's the inverse. And if I write the inverse, still the x and y's, my x values become my y values, and my y values become my x values. Now I want you to try to graph both of these 4 ordered pairs on the next 2. And this was what your inverses look like when they're separate. But one thing that you might be able to tell is if I were to plot these points on the exact same line or same graph, and if I draw this, the x equals y line, you might be able to see the fact that they are mirrored over that x equals y line. So they're the same distance apart on this line. So not reflecting over the x-axis or y-axis, but the axis that is created by x equals y. So that's how you're going to see if you wanted to check to see if you have the inverse correct. So now, when I'm actually looking for the inverse, I would just have to switch my x and y and solve for y. So in this case, if I rewrite this, so it says x is equal to y squared minus 1. And when I'm looking for the inverse, I'm going to solve for y. So I'm going to first add my 1 over, and then you have to take the square root. Remember this point right here, just like when we were solving, if we had y squared is equal to 4, you have a positive and a negative answer. Because you could have 2 answers when you're taking the square of something, because positive 2 is equal to 4 and negative 2 is equal to 4. So this would be my inverse. A lot of times we ask, is this a function? Well, if you were to graph this, if you know your original equation here is a parabola, if you were to draw a rough sketch, you would see that the horizontal line would give you that no, it's not a function, because the horizontal of the original, this is the original rough sketch, would say no, it's not a function. So I want you to find the inverse of b, 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 b. So here it's asking for what are the graphs of this equation. So one thing I could do is I can actually just graph this. And if you remember from chapter 5, this is showing me that this moves down 1. So if I plot that point, I go down 1. If I could make a table too, that might actually help you. So my point here, my vertex point would be 0, -1. So then you should be evaluating -1 and 1 and -2 and 2. This is where you just have to plug it into the equation. So -1 squared is 1. 1 minus 1 would give me 0. -2 squared would give me 4. 4 minus 1 would give me 3. 1 squared is 1. 1 minus 1 is 0. And 2 squared is 4. 4 minus 1 is 3. So now if I plot all those 5 points, and now that I have the original, there's 2 ways that you could graph the inverse. You could actually find the inverse of the function and then graph it, or I already have this handy dandy table. So now when I have my inverse table, it's just flip-flopping the 2 numbers. So my domain becomes my range becomes my domain. So again, flip, flip, flop, flop, flip. That's a 3. And then plot these 5 numbers. And when you're graphing parabolas, I would at least need to see 5 points on the graph, if not more. So if I now asked you, is my inverse a function? You would say, no, no, it's not a function. And the reason why you would say it's a function is once I have a graph, I can do the vertical line test, and it goes through more than 2 points. So this is not an inverse function. So you should try to do B by yourself. So we're talking about inverses. This is how we denote. This is how we show an inverse. When you have this little negative one, that's talking about an inverse. Or else you say the inverse of f, the f inverse. These are different ways that you can write the inverse. So my first question is asking, what's the domain and range? So one thing when you're doing this, you should always look to see if you have a fraction or if you have a radical. Well, in this case, I have a radical. So when I'm looking at this, I can't take the square root of a negative number. So my domain would be, okay, what does x have to be in order so that that does not become negative? So x has to be larger than or equal to 2. Because if that was 1, that would give me a square root of negative 1, which we don't want. If it's 2, if I do 2 minus 2, that's the square root of 0. That's the smallest I can get. Now my range, when you're talking about your range, you know you're going to only have positive numbers because you cannot take the square root of something and get a negative number. So y also has to be greater than or equal to 0, because if 0 is my smallest number I can take the root of, then 0 is the smallest answer you could have. So now it's asking for what's the inverse. This right here is talking about the inverse. Remember, this shows inverse, or else you could just write inverse of f. So I'm going to switch x is equal to the square root of y minus 2. So when I'm solving, the first thing I'm going to do is get rid of that square root. So that's going to be squared. So x squared is equal to y minus 2, and then add the 2. So my x squared plus 2, because you have to add over the 2, is equal to y. That's equal to your inverse function of x. So my third question is saying, what's the domain and range of my inverse? So my domain, when I look at this problem right here, when I look at this, I can put any number in for the x. There's no restriction on something that's being squared. So my domain would be all real numbers. My range, though, when I'm looking at my range, sometimes it's helpful if I don't give you a graph to try to draw a sketch of the graph. So this sketch of the graph, this right here moves it up 2. So you have to know your transformations. So if I move up 2 and it's a parabola, it's going to look something like this. So when I'm looking at this, you know that my range, my y value, would never go below here. So y is going to be greater than or equal to, because it can be equal to 2. So that's my domain and range. And the last question is this a function? Is my inverse a function? So again, if I reference that sketch, I can draw vertical lines all over the place. So yes, the inverse is a function. You should try the next one by yourself. So if you want to read this whole shebang up here, you should go do that. What this basically is saying is that when we have function, a lot of times like this area of radius squared pi, so the area of a circle, we have these things represent something in the real world. So we can't just flip-flop them. So when we are, strictly speaking, the inverse formula would be to solve for the remaining variable. So it's saying this function for this first one, this function is this. How long in seconds does it show to reach the water below? Well, one thing, I'm going to find the inverse of this. So again, the inverse means I'm still going to have my d is equal to 4.9 t squared. And I'm first going to get rid of the 4.9 times. So I'm going to divide by 4.9 is equal to t squared. Now I'm going to take the square root. We are talking about real life situations. If this was just a formula where I was asking for abstract thinking, we would put a positive negative here. But because we're talking about real life, when talking about time, you would just have the positive number. So it would be the square root of d divided by 4.9 will give you your time. Why? Because you can't have a negative time. So now my question is asking, how long in seconds will it take for the cliff diver to reach the water below? So it already gives us the 24. So we plug 24 in for d, just like this, and we would get 2.21 seconds. You should always make sure to have your labeling. You should try the second one by yourself. That's the last part, putting 6.6 and 6.7 together, because look at composition of inverse functions. So here's my original equation right here. What is each of the following? So first it's asking for my inverse. So when I'm going to be writing this, I'm going to have my x is equal to 1 over x minus, just kidding, y minus 1. Now I need to get rid of this division. So the opposite of dividing would be multiplying. So I'm going to take x times y minus 1 is equal to 1, just 1. Now since I see this times, opposite of multiplying would be dividing. So now I have y minus 1 is equal to 1 over x. Because 1 divided by x is 1 over x. Add my 1, my y value would be 1 over x plus 1. That's the same thing as my inverse function of x. This would be my inverse function. So now it's asking, what's the composition of my original function, my function of f, with my inverse function of f evaluated at negative or at positive 1. So first I take my inverse function, so the 1 over x plus 1, that was my inverse, and I put 1 into my equation. So it'd be 1 over 1 plus 1, and I have to put this answer, which is equal to 1, into my function of f. So my function of f was 1 over x minus 1, which is equal to 1 over 1 minus 1, which is equal to 1 right there. So even though we already found it, this basically is saying that since I evaluated both of these two functions at this number, original, and I got the same number out, that means indeed we found the correct inverse. That means this problem is indeed the inverse function. That's what this long part is saying. So right now I want you to try AB by yourself. And then you have a great, grand, wonderful